Okay, so using the Inspire, we are starting section 5.1, which is radicals and rational expressions. We're going to, before we get into example 2 with the graphic calculator, this is review. This section is all review. How do you multiply 2 radicals? What is the index on this problem? It says the square root of 8 times the square root of 12. So what, can you break up 8? 8 is 2 times 2 times 2, right? Is it 8, 2 times 2 times 2, yes or no?
Yes.
Yes. How do you break up 12? 2 times what?
2 times 3.
2 times 2 times 3, right? Yeah. Now, when you're multiplying, and if the indexes are the same, are these indexes the same? These are both square root.
Yeah.
The index is that little number on the ledge. So if you saw that, the index would be a 3, but this is a 2. What are we looking for? How many of a kind?
2.
2. So you can steal from, if you need to make up a set, with multiplication you can steal and get another, a set of numbers, factors to pull it out. So can anyone tell me what the square root of 8 times the square root of 12 is?
4 root 6.
And you got it. 4 root 6. So check, you can do that one. How do you add or subtract radicals? What has to be the same?
The inside.
The index and the inside. So they're both square root, that part's fine, but this stuff underneath is not. Can we see if we can get these to be the same? Yes, we can. So 12, does everybody agree, is 2, 2, 3?
Yes.
And which is 2 root 3. How do you simplify square root of 75?
3 root 5.
You're close. 5 root 3. Now can you simplify these?
Yes.
What's 2 minus 5? This is coming back to you.
What if you don't have the same number of names?
Then you leave it. Then you would leave it. Then you would leave it. If this were 2, then you would leave your answer. Okay, C. What are we looking for? Cube root. Now I'm gonna, if you are a visual learner, everybody look at this one. How do you break, I can't make this any simpler than what I'm about to do. How do you break up 8? 8 is what? 2 times 2 times 2, correct? How do you break up 6? It's 6, I'm sorry, x to the 6th power is 6 x's. And how do you break up y to the 4th? You've got 4 y's. Now what does cube root mean? What are we looking for?
3.
There's another one, there's another one, and there's another one. So if you were to pull out all your sets of 3, what do you have? What comes out?
8x squared.
2x squared y, and then what stays? The cube root of y. Now the other way you could look at this problem, a little bit more advanced thinking, do you recall how to write, if I asked you to write the cube root of x, can you write this as x to the 1/3 power?
Yes.
You guys know that, right? Well, look at your variables here. Do you know that the cube root of x to the 6th power is really x to the 6/3? Right? 6/3, 6 over 3. And what's 6 over 3? It's 2, x to the 2nd power. And what about y? We've got y to the 4/3. And isn't 4/3 1 and 1/3? So y to the 1st power is what came out, and the 1/3 is what stayed underneath. So anything with a fraction stays, any whole number comes out. You could think of it that way. How about about this one? What are they asking you to do? How many people want to FOIL this? I don't know. I don't know why, because it's saying add. The operation is add. So what are you gonna do?
Add like
Anything else? What do you get? What's root C minus root C? Nothing. Okay.
Every problem like that.
Yeah. Okay, example 2, everyone can do this. So let's do this on the calculator. We've got 40 to the 1/5 power. Did you get 2.09?
Yeah.
And it says use a calculator. And tell me what, using your Inspire, 225 to the 1/11 power. What did you get? 225. Whoops. 225 raised to the 1 divided by 11. And I got 1.63. Yep. Or 1.64, yeah. Good. All right, now, do you guys remember all these properties?
No.
Oh, yeah, you do. Watch.
No.
If I write them in simpler ways, what is x to the second times x to the third?
X to the fifth.
Well, you knew it. You just told me you didn't know it.
Well, it's common sense to me, I feel like.
Huh?
Because you got the formula, right?
Okay, then don't look at it then.
After so
But
long,
then I
it's,
do.
yeah, but it's just after so long, it's kind of.
Yes, it is.
All right, do you remember if you had this x to the third and you had it squared, what do you do with these two powers?
Multiply.
So remember that, power to power you multiply. What if you had something like this, x squared y cubed, and you were asked to raise them to the third power? What would you do?
X to the 6, y to the
X to the 6, y to the 9. Good. Do you remember what you do with a negative exponent? What do you do?
Put it under one.
You could switch it, yep. Do you know what you do when, let's say you had x to the 5th over x squared? Do you remember what you do with these? You subtract and you write x to the 3rd. What about if you have a fraction and you have a power outside? You distribute by multiplying, right? Well, guess what? You can do the rest of this assignment then. Because all it is basically the same thing. So see this problem?
That problem is,
Believe it or not, it's, you just said it, Lily. Go ahead, Lily, what'd you say?
You distribute the 2/3. Would you do, okay, so you do.
So you do 8 to the 2/3, and then you're gonna do r to the 3/4 times 2/3, and then you're gonna do r to the negative 3 times 2/3.
That's the negative.
I'm sorry, F. Yeah, this is review. Yes, yes, yes. And I'm gonna be brutally honest with you guys. In years past, we skipped section 5.1. We don't even teach it because it's so review.
this is so review.
So why are we?
No, because it's got variables.
So can we skip it?
Well, there's variables on this.
Now,
Letters.
you could do this part on your calculator. You could raise 8 to the 2/3 on your calculator.
Can do it, right?
Definitely.
So how do you do 8 to the 2/3? Let's look at it without, because Brad's gonna do it with the calculator. Brad, what'd you get?
What?
What did you, he's using his calculator to do 8 to the 2/3.
Oh,
That's not what
I was just,
Go on, do it.
I was actually doing equations.
No, do 8 to the 2/3 for us. Tell us what you got.
Yeah.
8 to the 2/3 is what? It's, okay, so he said it's 4. Now, without a calculator, this is the cube root of 8 squared. Is he right? Let's see if he's right.
Oh, I remember. What did I do?
So we've got 2 8s, right? Isn't 8 squared 2 8s? And isn't 8 2 2 2? And we have another 2 2 2. So we are looking for sets of 3. 2 times 2 is 4. He's right. Good job, Brad. So 8 to the 2/3 is 4. Now, you just told me above, that when bases are the same and you're multiplying, what do you do with these two exponents? What do you do with these two exponents?
You multiply them.
So in other words, when you did this one, you multiplied 2 times 3, you wrote 6.
Wait, which two exponents are you talking about?
Oh, you added them. So now I'm asking you the same problem.
But the 3/4 and the 2/3.
It says right there.
Oh, I'm sorry. I'm sorry.
But the R's exponent, S
I'm
exponent, you
listening
add
to you
them.
guys. Multiply these two, and I wrote it right there. Multiply these two.
I was like, you wrote it, so.
Yeah, I'm trying to get you guys to
So you get a half.
stop. These 3's cancel, and 2 goes into 4 2 times, so you have r to the 1/2 power.
Yeah.
Right?
How to do
So it's square root.
Yes, so Lily said it. This is the square root of r. What about these s's right here? These cancel, so you end up with s to the -2 power. You can't do this on your calculator, you guys. You have to know these properties. So how do you simplify this problem? You have a negative exponent and you have a square root.
So,
that. 4 square root times square root of
4 square root of r over
S.
s squared. There's your answer. Okay, next. Okay, so let's see how smart you guys are. You got x to the 1/2 power. And what does it appear that you're doing? What distributive property? So you multiply, right? So let's write it out. Let's write it. You're distributing. You've got x to the 1/2 power times x to the 3/4 power. And then you have minus x to the 1/2 power times x to the 3/2 power. Now, look at the properties above. When you're multiplying, this is what I was talking about. When you're multiplying and bases are the same, what do you do with these two exponents?
add them.
You add them. So what's 1/2 plus 3/4?
5.
It's 5/4. Good. Is there anyone lost on that? 5/4. You gotta get a common denominator. How about this one? Bases are the same and you're multiplying, so what do you do with these two exponents? You have to add 1/2 plus 3/2, which is 4/2, which is 2. Now, there's an ACT test coming around the corner. Does anyone know of another answer? Does anyone know of another answer that we could write?
You put it like this.
How could you write this?
You put it on 1/4.
She's still I know me too. I was looking at it.
Everyone got that? You should be able to convert it to another answer.
Will they be written like that?
I don't know.
Oh.
I don't know what kind of answer there, I wish I could give you that answer. I wish. Now, both of those answers are the same thing. And they're not gonna give you both, obviously, because they're both right.
Right.
Unless they asked, I could see them saying which is not a solution.
Yeah.
And those two are
Oh,
both.
they circle more than one. There's one.
Yeah.
That's the
Yeah.
first.
Yeah, they do that.
You're like, oh.
Okay, try another one. I see a power to power here. What are you gonna do with this power to power?
Multiply.
You're gonna distribute the negative exponent here and here, so you're gonna have x, you're gonna do -2 here, x to the -2 power. Now, what do we do with 7/4 and -2? Power to power u, power to power u, multiply. So you have to do 7/4 times -2. Anyone know what that answer is? -7/2. Are you with me on this?
Yes.
Okay, now all I'm doing is bringing down this. Now, what operation are we doing? Multiplication. So what's the rule when base, I see some x's here. What do I do? How do I combine these two? You add them. Is there a nicer way to say 5/2? So what's 2.5 minus 2? Right? So think about it. This is 2.5. 2.5 minus 2 is 1/2. How about 4? What's another name for 7/2? 3.5. What's 4 minus 3.5? 1/2. Right?
Yeah.
Now, you're making up the ACT test. Could you think of another way to write this answer? You know how else they could write it? You know how else they could write it?
Why is there so many ways to write it?
Oh, there's so many ways.
Why are there so many ways to say hello?
True.
Hola,
Because it's a language.
ciao.
Konnichiwa.
What else?
Konnichiwa.
Wait, I can't tell the
I'm looking at you. I am
She's like
looking at you.
Okay, alright.
Do you understand there's so
Sometimes I
many
think you're
ways to
looking
say hello? There's so many,
I was like, I'm
there's
not
so many
old, and
different
I'm just
dialects in
looking at it.
there.
Like turning
So
around,
just-
like, you should go like this, like, see if she's about
Yeah.
to.
Is it?
Wait,
What?
I don't know.
Is it a song?
They say it's a song.
Is what a song?
There's so many ways to say hello, I suppose. It's a song.
There's one
It
that
could be.
I just came to say hi.
That's all. I just said it.
I just came to say.
I'm gonna be quiet on that part.
You know that.
Next, Justin David. And
Millions, millions of views. Oh, wait, it's not. It's true, that's it.
Okay, what are they asking you to do on problem 6?
Rationalize.
Rationalize, what does that mean?
Means to, get rid of the non-dispersion.
Get rid of the radical. So what, how do you get rid of this radical?
Times 5, point, or square root 5.
Yeah, so what's the answer now?
7 square root 5 over 5.
Very good. And now what about this one? What's the conjugate?
3 minus square root
3 minus the square root of 6. What is this gonna be now? What's 2 times 3? And 2 times negative square root of 6? And then what's the bottom? 9 minus 6 is 3. So your answer is, and if you can break it up and simplify it, go for it. Okay, the remaining is your homework. The remaining is your homework.
I am in spiral.